Hey future Rustaceans, welcome to Rust 101. I'm Rusty Crab, and in this tutorial series I'm going to tell you everything you need to know to get started in Rust and develop your first project. I'm going to keep this series close to the Rust book, which is available online for free. I've put a link to the book in the description below. If you already know Rust and you want to go straight to the installation guide, just skip to this point in time and get started. Rust is the very young system-level programming language that is said to be as fast as C++, but at the same time is memory and thread safe, without using a garbage collector. The memory safety is guaranteed in compile time by Rust's ownership system, and borrow checker, which I'm going to exclusively cover in a later video of this series, since they're one of the most important features of Rust. I'm not going to lie, it may take some time to fully understand Rust's ownership system and borrow checker, since it's a completely new concept, and it may not even be easy, but when you fully internalize Rust's inner workings, you're going to be rewarded with a language that is even more powerful than C++. However, since Rust is still a very young language, its library collection may not yet be as big as the one of C++, but we will get there eventually. So, without further ado, let's start with how we can install the Rust toolchain, including its compiler rustc and the package manager cargo. So, we are here on rust-lang.org, which is the homepage of Rust, and from here we can just click on Get Started to get our installation guide. On the Getting Started website, we have a guide on how to install the Rust toolchain, and it also explains how to use the package manager, how to create a new project, and how to add dependencies to your project, and also how to develop your first Rust application. But the only thing we're going to do here now is we're going to copy this curl command. This is for Unix-like systems like macOS or Ubuntu 20. And if you are on Windows, you can click on other installation methods like this, and it will give you this website where you can scroll down and you see you have a lot of installers ready for Windows, for example. So let's say you're an x86 64-bit, like most of you, then you can just click on this installer if you use the Microsoft Visual Studio compiler, or if you use GNU, you can click on this one, and there you just have your other installers, and it also explains how to install Rust on Windows. But here we're going to install Rust on Ubuntu 20, and we copy this curl command. If you don't have curl installed, you can easily install it using sudo apt install curl, and in my case it says curl is already installed, so we already have the newest version, and we can just now paste the command into our terminal and install Rust. So we get a lot of information here, but the only thing we care about is that we want to proceed with the default installation and just press enter. And now the Rust installer will download a few components and install them, including our package manager cargo, and also the Rust compiler and the docs, and a few more we're going to talk about in later videos of this series. Now we see, great, Rust is installed, and we can go on with configuring the environment for our package manager. To do that, we can just copy this command and paste it into the terminal and go on with that. So what we want to do next is we want to see how we can set up our editor to program in Rust. I'm going to use Visual Studio Code, but you can use whatever editor you want to use. However, I'm going to show you which extensions are nice for Visual Studio here. There might be similar ones for the other editors, but we're going to go with that one for now. When you have Visual Studio Code installed, we can go onto the Extensions tab, and you already see that I have 3 extensions installed. And the first one and most important one is the Rust Analyzer, which is a IDE integration for Rust, and it provides us with a compiler check and some syntax highlighting as well. Then there is the code LLDB, which is for debugging purposes, and then we have a better TOM-ML extension, which is for Rust configuration files, and this just provides us with some syntax highlighting as well. So with those 3 extensions installed, we are ready to develop in Rust. Alright, let's start with our first project. To do that, we want to open the terminal and use our package manager cargo, since it can also help us to create a new project and run our project. So with the command cargo new and a name for our project, we can create automatically a new project structure. So we see here we created a binary application hello world package, and with that we can start. So we open the hello world folder in Visual Studio Code and see we have a target folder here, a source folder, a git ignore in case you want to upload it to Git, and we have a cargo.toml file. So that file will help us to identify our package, basically define our version, the name, and the author, and so on. And we also add our dependencies here. We will talk about that a bit later. But for now, the only thing you need to know, this is basically our configuration file for the project. And there's also a cargo.log file, which actually defines all the versions we use in our project. This is created automatically when we change our cargo.ml file. And it basically says which version we use and what the package name is and so on. Okay, next we have our source folder. It contains our main.rs file, which was created automatically. And we see we have a main function which prints hello world. And I'm going to talk a bit more about the syntax later on. But first, we're going to talk about our target folder. Our target folder basically contains our binary when we compile the program. So if we go into debug here, we see our build folder, and which is however empty yet because we haven't built the project yet. All right, let's just open the terminal again. And now we say cargo build. And cargo build will actually build our program. We see we're compiling hello world and everything was fine. So that's great. So now if you want to run the program, we can go and say cargo run in our current directory. And we see we printed hello world. You can also just say cargo run without cargo build and it will also automatically build our binary. What you also can do is to speed up your development process is you can go cargo check, and cargo check actually checks if your program is sound or correct without actually compiling it. In case you're wondering why it says unoptimized here, Cargo has two different ways of compiling code for your project. One is for development purposes and one is for release. So, and the development purpose build is the default one, but if you want to build for release, you can just go cargo build and then say -- release. And this will give you a new build for the release. You see it will create a release folder which has the released version of Hello World. Now you can also run that if you want to. The release version is a bit different. It takes a bit longer, especially for bigger projects. For the Hello World example, you won't see a difference, but you wouldn't want to build for release while developing, since it takes longer to build the program. In case you want to change optimizations for compiling, you can go into your cargo.ml file, and here you can basically say profile, and then you say profile dev. And in profile dev, you can now actually change your optimization level. So you basically go into op level, and then you say equal, for example, 3 for the highest op level. And if you now build for development, you go again, and it will now build with the up level 3. You can also do the same for your release version. You say profile release and create your own optimization level there. But we're not going to do that for now, since it is not important for our Hello World project. All right, let's now talk about the syntax of the main function. The function syntax starts with the fn keyword for function, and then followed by the function name and then the parentheses. Later on, we will put parameters in the parentheses, but at this time we have no parameters here. And we also don't have a return parameter. So in case, let's say you want to return something in that function, you would add an arrow and then put in the type of parameter you would want to return. For example, I want to return an unsigned 32-bit integer, then I would say it like that. But for now, we only print a string, so we don't have any actual return value. Now we see here we have this print line exclamation mark hello world. So you usually call a function using the function name and then parentheses and then put in the function parameters and then you end it with a semicolon. In this case, this is not a normal function, this is a macro. We're going to talk about macros in a later video, but for now you only need to know this is not a normal function. Yeah, and that's basically all for the main function. We open basically the function body with a curly bracket, and then we also close it with a curly bracket. All right, let's create a few examples to learn how we actually can define functions. Let's start with the functions that can print our name. So we start with the fn keyword, and let's call it print my name. And we want to give this function one parameter. What we're going to do there is we first start with the parameter name and then a colon and then the type of the parameter. For now, I'm give it a string literal reference. I'm going to talk about references and data types in a later video, but for now, you only need to know that we want to give this function a string. Okay, and we also don't want to return anything, we just want to print the name. Okay, let's do the open and close curly bracket. The default standard is basically to have the open curly bracket in the same line as the function name. I know some people might prefer this version, but the standard Rust convention is to have it in the same line as the function name. Okay, let's use our print line macro again and say print line. And what you need to know, even though the parameter is a string in this case, we always need to build a format string. So what we're going to do here is we use quotation marks and we say my name is, and then we use open and close curly bracket to put in our parameter. Then we put a comma there and say name and then semicolon, and we're done. All right, now you see we have a yellow underline here because we never called this function. So let's call it in the main function. So now if you want to call a normal function, we basically do the same as with a macro. We say print my name, and then we want to give it a name, and we close the function call with our semicolon. And let's say Tom as a name. I'd say let's build and run cargo, but first let's check actually if all the code is correct with cargo check. And we see, okay, everything's cool. And then let's call cargo run. And we see hello world, and then my name is Tom. So the next thing we want to do is let's actually create a function that returns something. Okay, let's call this function create an ID, create ID. And it has no parameters, but will return a unsigned 32-bit integer. All right. Now, the syntax for returning something in a function is usually just you write, for example, a number here as, for example, u32. So we say that this number is actually an unsigned 32-bit integer, and that's all we'll have to do. So we don't use the return semicolon syntax as, for example, in C, but we just say it like that. There are other cases later on I'm going to talk about where we have if-else cases where we want to return something in case another condition is met. Then we have to use this return function, but for now we don't have to use that. But the standard one is just, for example, return a 4 like this without semicolon. Okay, so now we have basically a constant ID of 4, and let's say we want to print line this ID as well. We say my ID is, and then we can actually also in the print line macro call this create ID function. So let's say create ID, and we are done here. So our print line macro now will know this returns a unsigned 32-bit integer, and it will put this into our print line function. So if we run this again and say cargo run, hello world, my name is Tom and my ID is 4. So now you see how you can actually return a parameter or return a value, how you can give a function a parameter. If you want to give it multiple ones, you can just separate it by comma. And yeah, that's it for today. Thanks for watching, and I hope I'm gonna see you next week.